Explain like I'm 5. Why is it mathematically consistent to allow imaginary numbers but prohibit division by 0? Couldn't the result of division by 0 be defined, just like the square root of 1? Division by 0 is undefined in a very different way from the square root of 1. For the square root of 1 there is no real value it could be. So if you invent a value for it to be, that's the issue solved. For dividing by 0 there are too many values it could be. 0, 0 could be literally any value from infinity to infinity, or even an imaginary or complex value. Creating a new value for it to be just makes the problem worse. It's not necessarily that it's prohibited. You could define an imaginary number to the result of dividing by 0. It's just that it's not useful, so what is the point? Mathematics doesn't really have any global rules. Operations are defined in some contexts and not in others, depending on what is interesting or useful. For example, if you're modeling a population of animals, you might well forbid negative or fractional numbers of animals, let alone complex numbers. There are systems in which division by 0 is defined, like the extended real numbers. But they aren't really all that interesting, and it's almost always more convenient to leave it undefined. The complex numbers have a very interesting structure that is convenient to use in many contexts. Explain like I'm 5. Think about your question. What's 5? 5 things divided into 5 groups. How many items per group? That's 1. What's 5? 1 things divided into 1 group. How many items in that group? That's 5. What's 5? 5 things divided into 0 groups. Or 5 things that aren't counted in a group at all. It's not 0. The group isn't a thing. It's not that we need to invent a thing. Your question is designed to be unanswerable because of how it's constructed. Division by 0 isn't prohibited. It's just not usually useful. It's infinity. There are rarely times when infinity is used in day-to-day equations. Imaginary numbers are everywhere in, say, engineering, so they are much more useful to work with. Yes, you absolutely can. This is done in several mathematical objects. The terms to Google are the projectively extended real line and Riemann sphere. In all such objects you do lose properties, as others have shown. But this isn't any different to imaginary numbers. Including means you lose some key properties of the real numbers, namely the ordering. Because I can imagine a number that isn't real. But if I divide something among 0 people, then no one gets anything. Everyone involved gets 0. There simply isn't anywhere to put it. How much was being divided? Who can say? No one was on the other side of the divisor to receive it. Instead of thinking of division by a number, say 2, think of it as multiplying by its multiplicative inverse. 1, 2. Now 2 in the usual context has a multiplicative inverse, as do all the other reals and even complex numbers. That is, there exists another number you can multiply and get 1 as a result. 2x1 2 1 2x2 1. Now 0 doesn't have a multiplicative inverse in our usual multiplication. It multiplied by anything is 0. So trying to divide by 0 doesn't make sense because you can't multiply by its inverse. It doesn't have 1. Maybe I'm just simple, but my reasoning is this: take 1x and plot it on a graph varying the values of x near 0. You'll see that as you approach 0 from the negative side and from the positive side of the number line, the values don't converge on some number. Instead, they tend towards negative and positive infinity. In this way, the value of 10 can't be defined because the result differs depending on which side you approach it from. A definition should be consistent. Infinity is infinitely many things. 0 is infinitely little things. Infinity is the same thing as 0, just the other end of the spectrum. You can't divide by 0 because you can't divide by infinity. Because the multiplicative of a number by itself must equal 1, i.e., 3 by 1/3 1, 8 by 1/8 1. But when looking at 0, 0x anything 0, there is no multiplicative because anything x 0 0. Therefore, it's non-divisible. Division is the concept of sorting into a number of groups equal in value. Dividing by 0 is asking something to be sorted into 0 groups. It makes 0 sense to tell someone to divide 100 into 0 groups. Imaginary numbers are a fun thing to think about. But for realistic purposes, the number can be defined with positive numbers. Usually imaginary numbers are encountered in waves. Either it's in attempting to formulate the wave before it ever existed, or it's used to represent a value less than the median of the wave that can be represented by positive numbers. What would you do? Would you treat the answer as infinity? It's conceptually impossible. Like, literally unimaginable. How do you divide 6 elements into 0 groups? You can't. You can conceptually divide 6 elements into 0.0003 groups. Because that is conceptually equivalent to dividing 60,000 elements into 3 groups. Multiply both dividend and divisor by 10k, and it maintains the ratio. But if you try that with 0, it doesn't work. 6 by 10k equals 60k. 0x 10k equals 0. You can perform any multiplication you want, any division you want, and the divisor will always be the exact same number. We commonly think of numbers on a line, with some bigger than others. This is a one-dimensional approach to numbers. However, we can also think about numbers in a two-dimensional space similar to graph with x and y axis. They are harder to conceptualize in terms of, say, apples, but they have a lot of uses. One example is with electricity. You use imaginary numbers when calculating the amplitude and phase of radio waves. They were originally called imaginary because it was thought they were useless. Now we generally call them complex numbers. Math isn't reality. It's a model for reality. Nature doesn't care if you try to divide by 0. The universe won't end. It won't even notice the attempt. Decisions like dividing by 0 are made on more of a what doesn't break our model of reality scale than a what makes the most sense scale. 3 cookies, 0 children. Think about it rationally. How can you divide something by 0? Imaginary numbers are useful. They have applications in applied and theoretical physics, aerospace engineering, electrical engineering, and so on. Basically, they are used everywhere because they are much more convenient than any alternatives when doing calculations. An object that represents real division by 0 has much less usefulness in comparison. People do use it though, just in a theoretical context. It just breaks too many things. Imaginary really gets people. We have real numbers. Most numbers you think of are real. Pi, 3, sqrt, 1, etc. When they discovered that you can have sqrt1, it was a new set of numbers. They are not real numbers. So let's call them imaginary numbers. Later they became complex numbers. If you take 10 apples out of a basket and give them to 2 people evenly, you are giving them 5 each. Division by 2. If you take 10 apples out of a basket and don't give them to anyone, nothing happens. Division by 0. If you take 10 apples out of a basket and decide later who to give them to, that's okay. Division by x.